Welcome to second part of this tutorial. Now begins the exciting part of this video tutorial. Before we move ahead, I would like to mention that we are not going into the details of Docker in this video because that is a big topic in itself. Nevertheless, I will give an overview of Docker and some important commands in this tutorial. Before explaining what Docker is, let's first understand what were the problems which Docker solved for us. Come across situations when an application or a feature is running perfectly fine on our local machine, while the same feature behaves weirdly on UAT or production, which is due to the differences in running environments and production in our local machine. Another thing is the problems and the headache associated with maintaining VMs. Say you have a big enterprise monolithic application which you have converted into microservices. Ideally, you would like to deploy each microservice on a separate VM, which means you have a growing number of VMs, and for each VM you have to pre-allocate resources, which leads to mismanagement of resources. Another problem is scalability. If we have to scale the same application, which is based on microservices, we will have to add more and more VMs. And as you know, VMs have to have their own operating system, and you always have to pre-allocate resources for them. Now moving on to Docker, what Docker is and what it does for us. As per Docker official website, Docker is a tool for building and sharing containerized applications, which in simple terms means that Docker is a tool which creates a snapshot or a blueprint of our application, which can be then shipped as a self-sufficient package to run on any environment. When I say a self-sufficient package, that means Docker has all the information and resources needed for running the application. Unlike VMs, Docker shares the underlying host operating system, and we don't have to pre-allocate resources for any instance. In the definition we see the word container. A container is actually a running instance of a Docker image. And to deal with scalability with the help of Dockers, the only thing I had to do is to spin up a new container instance rather than adding a new VM. If you guys want to learn more about Docker, there are plenty of awesome videos on YouTube. And I'm going to share a link here which is not an affiliate link, but I have myself watched it and found very helpful. I'm going to put the same link in the description below. Now we have to set up our Docker instance on our machine. Open your browser and type in docker.com, which is the official website of Docker. Right here, click this button Get Started. And here you have the download options for Windows or Mac. Choose the option you want to download for. If you have to download for Windows, say download for Windows. While the download begins, you can check other things here. There's a button See Docker Desktop for Mac and See Docker Desktop for Windows. Let's click here since I'm using Windows. And there are some instructions for installation and to get started. See here, Docker Desktop for Windows and installation instructions. Let's double click for Windows installer to run the installer and move on. Check the version and to run a simple hello world. Quite many options here. In order to learn more and to go deep through the documentation, here's a link for Docker Desktop for Windows documentation. Also, here you have something Play with Docker, which contains some tutorials and lab environment. You can check that also. So install the Docker on your machine and let's move to the next step after that. Alright, now that Docker is installed on your machine, let's go to command prompt to make sure that Docker installation has been successful. Let's simply type in a command Docker version. This will get information about Docker version and other things. So since it pulls up information, that means Docker installation has been successful. Also, another thing is that here under the taskbar, in the Show Hidden Icons section, you will see this Docker icon. The tooltip says Docker Desktop is running. It gives indication that everything has went well. If you right-click the Docker icon, you'll see many options there. Docker Dashboard, where you can get the instances and images which are running or stopped. You can even start the containers from there. Settings for Docker, updates and troubleshooting if you have any problem. And you can switch from Windows to Linux container mode or Linux to Windows container mode. And about Docker Desktop versioning and other things again, which we saw in the command prompt. The documentation about Docker, quick start guide, Docker Hub, which is the registry for storing our Docker images. And here appears your registered Docker Hub repository, which I already done, so that appears here. And you have options for Kubernetes. We can restart Docker and we can quit Docker Desktop. We don't need to go into these details. Only thing we have to make sure is that Docker Desktop is running. Yeah, this is the dashboard for Docker, which inadvertently we clicked. Alright, now let's move to Visual Studio Code project. Now in order to make our application containerized, the first thing we had to do is to add a file, which is a special file called as Docker file, and its name has to be exactly as Docker file. It is that file in which we give instructions to Docker daemon that what should be included in our Docker image, what our image should be based on. And that file has to be at the root level of our project. That means it should be outside the source folder. I simply click here and add a new file, name it Docker file. See, as soon as we type in the correct name, Docker icon appears here. Hit enter. Now, if you see, the file isn't at root level, it went inside source folder. Let's move it out from the source folder. Drag it here and confirm move. Now the file is outside source folder. And now we have to bring it, giving instructions to Docker via this file. In the interest of time, I already have prepared the contents of my Docker file. I'm simply going to paste them here, and then we can go line by line in detail. This is all we have to mention in our Docker file. Let's first save this. The first line is a comment. Anything which has hashtag as first character is treated as comment. So if you have to write a comment, just write hashtag and type in anything as comment. The second line is actually where our instructions for Docker start. The first thing tells Docker to pull a node latest image from Docker Hub. Let me give you a quick overview of what Docker Hub is. Docker Hub is a service provided by Docker for storing and sharing Docker images. There are numerous packages or images already available which we can pull and use in our applications. Also, we can store our images there. For that, you have to simply go to Docker website and sign up with an account. I already have signed up, and as soon as I sign in, I land on my Docker Hub dashboard. And here I have a couple of repositories created. I can create another one here. If I click a repository, it also gives a command which can be used to pull this image anywhere. I simply can share this command with my team so that they can pull my repository on their machines. Let's go back to Docker. So the first thing, as you know, for an Angular application, we have to have Node in order to run various commands. So here we are telling Docker to pull a node image which will be as base image from Docker Hub, and colon latest indicates the tag of that image. There would be various images available on Docker Hub, but we are instructing Docker to get the latest image. After that, we are declaring a working directory in Docker. Also in the first line, we are naming this step as this image as node so that we can refer it to at any point if needed. The second line says that we are declaring a working directory in Docker virtual environment. /app will be our working directory. The next line tells Docker that copy package.json from current directory. The current directory is where Docker file resides, and that is at the root level. So here we are telling Docker to copy package.json file from our root directory and paste it at the root directory of working directory, at the root level of working directory, which is /app. Why we copy package.json first file? Because it's that file where all the dependencies are defined and which needs to be installed in order to run the application. Once that package.json file is copied to the root level of our working directory, the next thing we instruct Docker to do is that run npm install, which is usually what we do when we pull up or clone a Git project of Angular or get from somewhere. The first thing, in order to make sure that this application is running, we do to run npm install. The npm install installs all the dependencies needed for the project. Similarly, we are telling Docker here that run npm install command so that all the dependencies defined here are installed for the application. Next, we are instructing Docker that we need to copy everything from root. Dot means the root, from root directory, current root directory, which is this, to the root directory of our working directory, that is here. After that, we are telling Docker that we would like to run the command npm run build so that our project is built. This is stage 1, where we copy the stuff and we build it. Then there's stage 2, which is the stage for runtime. Here we are telling Docker to get an Nginx server image from Docker Hub, and that image should be tagged as Alpine, because Alpine images are smaller in size as compared to other tags. And after that, we are telling Docker that we have to copy from node, which we declared here, this stage, our build stage, we had to copy /app/dist and place it under user/share/nginx/html. This folder resides inside our nginx server. We had placed the compiled stuff of our stage 1 and put it inside this folder on nginx server, which is the reverse proxy server. If you already know that dist folder is the one where our compiled stuff of Angular application resides. And finally, This is optional one, but we are writing here expose 80, which means that we are exposing the port number 80 for Docker. That inside Docker environment, this application will be listening on port 80, but we can't access that from our local host. This is the port 80 for Docker virtual environment. That's so simple for this application. Next, let's now build our project with Docker commands to create an image. Now that our Docker file is ready, let's now go ahead and build our Docker image. Open your terminal in Visual Studio Code. If it's closed, simply press Ctrl and tilde key on Windows. For Mac, it will be Command and tilde. And type here Docker space build space T for tag, and then our image name like free app colon latest. If we don't mention the T tag here, then we can't mention our tag. But since we mentioned -t, that means we are giving the tag also. Let's give the tag as latest. And space, then we have to mention the path of the directory where Docker file is located. We simply type in doc because that's the root directory where our Docker file is. This command will be looking for a Docker file at root directory. Hit enter. It's building our Docker image. For the first time, it's going to take a while. Alright, so a Docker image is created. We can simply type in Docker space images. You can see here our image free app, the latest tag got created. Next, let's run our Docker image by a simple command docker run. Alright, also there are many options available for Docker run. You can check the documentation for different flags, for different attributes available for the run command. We are going to use your Docker run space -d. That means in detachable mode, we want to run this instance so that it quickly runs our application. Then space -p. Why we are mentioning this flag p here? This indicates the port mapping. As you remember that we exposed port 80 in Docker environment, but we can't access that from our local host. We have to map that port 80 of Docker to our local host. Let's say we want to map the port 8001 of our local host to that port 80. First port is our local host where we want the application to listen at, and second port is the port where the application is listening inside Docker. And then image name free app. You see it generated a long ID, which means that a container has been started. Also, in order to make sure that container is running, that we can type in docker space ps. It's the list of containers running. So our containers running, the container ID is this, and image it's using is free app. Now, in order to check this application inside Docker, we have to use port 8001 of localhost. Let's go here, port localhost 8001. If you remember, by default, when we first time launched this application in Angular, when we grabbed the template from internet and we launched the application locally, it was listening on port 4200. Right now it's inside Docker, listening on port 80, which we have mapped to our port 8001. Hit enter. Yes, we got the application, but right now the magic is that this is not our local application. This is running inside a virtual environment created by Docker on our machine. So our application is running inside a Docker container locally. We have one container instance running locally on our machine, and we are accessing that application which is inside the Docker from port 8001 of our localhost. So our application has been Dockerized, and the next step for us is to now deploy this application on cloud. And the cloud environment we are going to use is Microsoft Azure. As discussed earlier, we'll be using a free account where we can deploy our container instance. This application is running inside Docker. However, we can also running our application locally, which we do as usual and which will be listening on port 80. We can still type, let's clear the screen here. We can still type ND serve. Even if we have created a Docker image, we have a container running. That's not going to interrupt our local running environment of the application. We can still type in ng serve to run our application locally. It's a warning, but it will still continue. Started compiling. It's going to take a while. I skipped that part here. And if you see, the application is still listening at port 4200 of localhost. Let's try to access that and see what happens. Localhost port opens 4200, the default port for Angular application. Let's hit enter. Absolutely fine. See here, the application is still running in our local environment in the same port where it used to be when we started the application. Also, we have the same application running inside our Docker environment, which is listening on port 8001 of localhost. So we have same application being accessed from two different ports on our machine. Even if I stop this application here, and we'll see here I cannot get access this application because this is running locally. See here, unable to connect because I stopped the local instance. See here, the Docker instance is still running because that's in a separate virtual environment on our local machine, while as our local host port stopped listening because we stopped the application. Even if we stop Visual Studio Code, this application will be still available for us at port 8001 because this is inside a Docker environment on our machine. So that's pretty much, as said earlier, you can go on Docker official website to check the documentation for further commands and you can play around with the things. You can check the lab stuff there. But for now, the next thing is to deploy this application on cloud environment. Stay tuned and watch next. Thank you.